Okay, guys, let's learn. Let's start section 7.3. This might take us a little bit of a while to get through, but let's just start it. Section 7.3, part 1. I'm going to actually call this part 1A because I think it's going to take us I think it's going to take us 3 or 4 sections. But anyways, so section 7.3, part 1A. We're still finding volume. But this time we're going to find it by using what's called cylindrical, or a cylinder, cylindrical shells. Okay, so this time instead of using circles or discs, we're going to be using cylinders. Okay, so let's take a look. I'm going to give you this. Y equals negative x squared plus 4. Okay, x is greater than or equal to 0, and y equals 0. And we're going to go about the y-axis. Y-axis. Okay. So let's talk about, we're going to try to compare these. We're going to do the disk method, which we've been doing, and now we're going to do the cylindrical, I'll just call it the shell method, cylindrical shell. Keep in mind that both of these, if we took the time to do both, I'll see, maybe eventually I could show you both, they would give us the exact same answer. We're doing the same thing, just a different method. Last section was the disk method, and this is the shell method. But in the end, it gives you the volume, the exact same thing. But let's, and again, if you want to use your calculator to draw this, that's okay. It's a parabola. It's going up here at 4. Okay, it's just this half of the parabola because x is greater than or equal to 0, and then it stops here because y is equal to 0. So we're bringing that around. So now when we bring it around to the other side, then it becomes over here. Okay, and here is our disk. Here is our disk. Okay. Now let's do the same thing. So let's do that same shape over here. Okay, parabola over here. But for a cylindrical shell, you drop it in, you're going to drop in an actual cylinder. Okay, and it's you know, a hollow cylinder, and then there's one right after another. Here would be, you know, like another cylinder. Okay. It's one cylinder right after another, dropping one right in after another. So let me draw just one cylinder, just like here. Remember the discs? I could even draw it here. The discs, right? There's a whole bunch of discs. Okay, here there's a whole bunch of cylinders. Okay. So let's just draw one of each again. So here's one cylinder, and here's one disc. Okay. All right, so for the disc, notice if we're going about the y-axis, okay, we actually cut it like this. Our thickness is here, our thickness is dy. So thickness is dy. But here, if we're talking about our cylindrical shell, if we're talking about our cylinder, the thickness of the cylinder is this right here. How thick is this cylinder? So this, even though we're going about the y-axis, its thickness is dx. Okay. What else do we want to say? I think that should be okay for right now. So for this one, it's a little bit different. Here, if we're going about the y, its thickness is dy. Here, if we're going about the y, the thickness of the cylinder is actually dx. So they're kind of opposite each other. Let's talk about this. What happens when we cut and unroll this cylinder? So here's my cylinder. Make sure we can still see. Okay. Let's just take a look at a cylinder. Okay. So if I cut this cylinder and unroll it, okay, we really have a rectangle with a little bit of thickness, and that's my dx. We have this rectangle with a little bit of thickness. Okay, So my thickness is dx. How thick is this actual cylinder that I'm cutting? Okay. This is the height of the cylinder. The height of the cylinder, but let's look back up here. The height of the cylinder is a y distance. The height of the cylinder is a y distance. What is this distance? This is always hard for kids. This distance is this distance going around. Take a look. Let me roll this up real quick. If I had this piece of paper, right, I make my cylinder, look at this is my circle. This is my circle, but if I cut it and unroll it, it becomes the side of a rectangle. So this circle, the distance around is the circumference. That's the circumference, and it becomes the side of my rectangle. So this is 2 pi r, because 2 pi r, because that's how you find the circumference of a circle. Okay, and let's look, this distance here, that's my radius. It's kind of weird. Let's think about this. This distance here is an x distance. So my height is a y, and my radius is an x. This distance, normally we would start down here, right? But this is my x, and this is my y. X, y. When I do this x, that's my radius. When I go over, that's my radius. Okay. All right, so we could even put this if we wanted to, 2 pi x. Okay. All right, so let's actually try this one. Let me rewrite it. Let's write directions. If you just want to watch, you know it pretty good, but what is it? So specifically now this one says use cylindrical shells. Use cylindrical shells to find what? To find the volume generated by rotating the region, bounded by the given curves, about the given line. So same directions this time. The only difference is it's specifically asking us to try a different method, cylindrical shells. But both methods should give us always the same answer. Okay. All right. So let's try. Okay. Let's go back and try that first one. Y equals negative x squared plus 4. Okay. X is greater than or equal to 0. Y is equal to 0, and we're going about the y-axis. Okay. All right, so let's get our picture again. Remember this guy's opening down, right? It's going at 4. Remember it's negative, and then x plus 0 squared plus 4. Again, if you use your calculator, go for it. That's no problem. So 0, 4, it's opening down. We really only care about the first quadrant. Basically, this is saying x is greater than 0, and we're stopping at when y is 0. So we really just care about this guy right here. Okay. But when we spin it around, then it creates this side over here. All right. So we're not going to do the discs. We're going to do the cylindrical shell. So let's just literally drop in one cylindrical shell. This is just one of a whole bunch, right? The goal is to add all the cylindrical shells up. So we want to add them all up, and that's where the integral comes in, right? The thickness of this is right here, going left to right. So the thickness is dx. So we want everything in terms of dx. Also keep in mind we only want half of it, right? We originally started with this shape here. So we know that we're going to go from 0 to where this point is. So we want where the parabola, where the y value is 0, right? Where the y value is 0, that lands on the x-axis, and that's where we want to stop. Or we could say we want to stop where y equals 0, so we're going to plug a 0 in for y. Okay, so 0 is equal to negative x squared plus 4. All right, let's solve that. You could add an x squared to both sides. As in a factor, take out a negative, x squared minus 4. But either way, because the negative doesn't play a part for solving for x, so this guy factors. X, we could divide by -1 to get rid of it. X plus 2, x minus 2. Okay, so that means x is either equal to 2 and -2. Now remember, this is 2, this is the -2. But I'm only going from when x is greater than or equal to 0. So I'm only going this distance, so I'm going from 0 to 2. Okay, it does, the whole parabola does meet over here, but remember, I'm only doing when x is positive. So I'm only going from when 0 to 2. Okay. All right. So now we got to fill this out, right? So we want to find the area of the cylinder. What would it look like if I cut this out flat? If I cut this and lay it out flat, if I cut it and lay it out flat, I have this thickness of dx, okay, and then the rest is this height here, which is y, and then this line right here is going around the cylinder. So this is 2 pi r. Okay. So really, we have 2 pi r times y times dx. Okay. Now, this looks crazy because I need everything in terms of dx. So now we just kind of got to go back to the drawing board and make everything in terms of dx. Well, we said that this radius is going this way, whether I do it down here or up here. And so that radius is nothing more than x. So let's do it down here. So we're going from 0 to 2. 2 pi, the radius is going left to right, so the radius is x. And y is perfect, but I need it in terms of x. And that's where this guy comes in. This is going to be my y value, is going to be negative x squared plus 4 dx. And in that quickest situation, we got everything in terms of x, and we're good to go. Okay, so we're going from 0 to 2. The 2 pi we can maybe put outside. We remember, just don't forget about it. And then we just have x, negative x squared plus 4 dx. Okay. Now it's old school stuff, right? Distribute. So we got negative x to the third plus 4x. That's the integral. Just don't forget about this guy. Make sure you can see. Then we're going from 0 to 2. Oh, no, wait. What am I doing? Hang on. We haven't taken the integral yet. Back that up. Okay, so let's go right from there. Okay. So we distributed. Let's distribute. We got negative x to the third plus 4x, but we have not taken the integral yet. We simply distributed. All right, so we still have dx. Okay, that looks better. All right, so now let's take the integral. Add 1, divide by the new, so 1/4 x to the 4th. Add 1 takes us to squared, so x squared 4 divided by 2. If you want to change that to 2, that would probably be a good idea. Let's see. Maybe I'll slide this up just a little so we can see. Okay. Okay, so now we've taken the integral, so now we're going from 0 to 2. That looks better. Let's do negative 1/4 x to the 4th. Let's go ahead and change that to 2. If you changed it right away, perfect. If not, you can do that now. Okay, and then we just plug in the 2 to the 4th plus 2 and then 2 squared, right? And then minus, this guy's nice, we plug in a 0, we get 0, plug in a 0, we get 0. So that's beautiful. All right, and then we just work this out. This actually gives us -4, but then this gives us 8. So this maybe I should have done this a little bit different. This gives us 4, but don't forget about our 2 pi. So our 2 pi, I ran out of room here. We have to make sure that we bring down the 2 pi. So what is our volume? Our volume is actually 8 pi. Okay. All right, let's try another one. We got our directions. We know our directions. Now it's just a matter of practicing. Let's do this one. Okay, so we're doing, let's see, make sure that we can see it here. Okay. All right, let's do y equals 2x squared, y equals 0, x equals 3, and we're going about the y-axis. Okay, I think we'll start out just going about the y, and then we'll change in a little bit. All right, so let's graph this. If you want to do the calculator, that's probably a good idea. It starts at 0, 0. Let's keep in mind that let's see, y equals 0, so that cuts us off here, right? What else? X equals 3, so that cuts off here. Let's go ahead and draw this. I think maybe, actually, now that I think about this, we might have to say something about same thing again, that x is greater than or equal to 0. We kind of want to make sure that we only have that first quadrant. So I think we only want this situation here, this parabola side. So let's add that in, actually. And then we want to stop when x is 3. Okay. Okay, so for this one, I think this one might be, so now this side comes into play only when we start revolving it around. So once we swing it around, we get this, okay? And then in this case, let's draw in a shell. So let's go here, and we'll drop in one shell. Okay, that's just one of many, right, that we're trying to add up. Okay, this one might be not too bad. We're going from 0 to, this line's always the same. So we're going from 0 to when x is 3. We want our cylinder basically to start here, and then we're going to stop when x is 3. So here we're going from 0 to 3. And if we take this cylinder and cut it and unroll it, this is y, this is 2 pi r, because that's the circle. This, let me trace it, this and this are the same thing, because once I cut it and unroll that circle or that cylinder, then I have a straight line. Okay, and then remember the thickness of my cylinder, the thickness of the cylinder is dx. However thick, and the goal is, right, to get it smaller and smaller and smaller, but technically right now I have a little bit of thickness of dx. Okay. So to find that, I do y times 2 pi r times dx. And this guy says it all. This guy, if this is dx, even though we don't do much with it, because this is dx, everything has to be in terms of x. So from 0 to 3, those are x values. Okay. How do I change my y to an x value? That guy right there, 0 to 3. So that is going to get replaced, 2x squared, 2 pi, and then what's my radius? My radius is left to right, whether I do it down here. Down here is where we usually think of x, but it's also up here. To my parabola, that distance is simply x. Okay, so now we can pull out all these numbers. We can pull this out. We can do 4 pi, integral from 0 to 3, and so then we've got x squared and x. So x to the third dx. And now we're in really good shape. Add 1, divide by the new, so that gives us x to the fourth divided by 4. Okay, that is, we took the integral, so now we're going from 0 to 3. I could even bring this back in. Usually I hold off, but how come here I might want to bring this back in? Because now I can even cancel those 4s. So I don't even have to worry about those. So I really have pi x to the 4th. All right. Plug in the 3 to the 4th, and then plugging in the 0 gives us 0. So the volume, if I spun that around the y-axis, would be 81 pi. Okay. All right, let's try one more. This one's a little bit harder. Maybe, let's see. For this lesson, oh, maybe. Yeah, let's do one more, and then in the next lesson we'll do some more. They get just a little bit harder. But let's at least do one more for this section. The hardest thing, the hardest thing for this one is just maybe getting a good graph. So if you use your calculator and that helps, go for it. Okay, 8x minus 12. That's kind of a hard one to work with. Let's make sure it focuses. See, even the camera didn't like it. Okay. Y equals 0. Okay, yeah, this one's okay. Y equals 0 is good enough. And then about the y-axis. Okay. So we got some options on how, again, if you just want to go to your calculator, then you're good. This, we might need this to factor eventually anyways. So if we take out a negative, we're left with x squared minus 8x plus 12. And then if we factor it again, what multiplies to 12 but adds to be negative 8? It's what, negative 2 and negative 6. So x equals 2 and 6. Okay, and this, remember, this a is the same a as if we had it in vertex form. So this negative is telling us that it is opening down. Okay, so what we could do is we could say, hey, we know that it hits the x-axis at 2 and at 6, and we know it's opening down. So we could just maybe estimate this. Actually, the vertex, we've got a couple ways. We could do, for the vertex, right, we could do negative b over 2a, or it's halfway in between these two. So halfway in between would be 4. Okay, now that gives us the x value only, and then if we wanted to plug in 4, we could plug in 4 and actually come up with the y value. We could just kind of approximate anyways, since we're just doing a sketch anyways. And so they're talking about this parabola opening down. I'm going to stop at the x-axis because that's the same as where y equals 0. Okay. So again, calculator's fine. If not, you got some options there. It took maybe a little bit of work, but we're okay. All right, and so then, now that's what we're spinning around. That's kind of cruddy parabola, but that looks a little better. Okay, so we got this parabola over here. Ooh, that one actually looks better. Good. Okay, and this is kind of important. Think about why this is actually important. This is where it starts, and this is where it stops. So this kind of paid off, and if we didn't do that, remember we have to figure out where we're starting and stopping, we would have to take the 0 and plug it in for y, and basically do the same thing all over again, right? We would plug 0 in for y, and then we'd have to come up with how to solve that. We'd solve that the exact same way. If you use your calculator and you calculate like where it is crossing the x-axis, that's okay. That would be okay too. I would definitely be okay with that. All right, so this, let's draw in one shell, like one shell. Maybe we'll do 3 if it gets too cumbersome. If I change colors, I don't want to spend too much time, but sometimes it's nice to get a visual. Okay, so let's put in like this far cylinder. We'll just touch here. Okay, come down. As we move in, let's do this blue one. Like this cylinder, would just be like kind of like right here. As it's coming on that downward side, then it would cut, oops, sorry, it would cut right there. Okay, we're just dropping cylinders in, one right after the other. That just happens to be two, and they're fairly spaced apart, but we're just dropping cylinders in one right after the other. Okay, so we're going to the integral. The thickness of this cylinder, the thickness of that cylinder is left to right, so that is dx. So this works out perfect. This is 2 to 6. Okay, let's cut it and unroll it. Cutting it, you know, either one, we could cut the pink one. It doesn't matter where you cut it either. We could cut it here, right? Cut it and unroll it. This distance is up and down. I'm cutting it on the y. This line here is this exact line going around, so that's 2 pi r. Okay, and then the thickness going back is dx. Okay. So we know it's y times 2 pi r times dx. Okay. Now we just got to take the time to plug it in. So let's see. Let me even rewrite this. Let's rewrite this. 2 to 6 y 2 pi r dx. Okay. So 2 to 6 y. I need everything in terms of x, and I can even double check. I got to even start making sure that these are x's, which I think we're good. So this little thing, even though we don't do much with it, it determines everything. So how do I change y into x? Right here. Negative x squared plus 8x minus 12. Then comes a 2, then comes a pi, and what's my radius? My radius going across this way, that's x. That is x, dx. All right, so this one just gets a little bit messier, but that's fine. Pull out the 2 pi. What else do we want to do? We can distribute. Really, the only thing, maybe I'll do it in this color here. We just have this guy. If the 2 pi goes out, we just have this guy that we have to distribute to those three. So let's at least do that in one step. So that gives us what? Negative x to the third plus 8x squared minus 12x. Okay, so now we're all organized. Now we can actually take the integral. How are we doing on space? Let's slide it up just a little. All right, so add 1, divide by the new, negative 1/4, because this is x to the 4th, those match, right? Add 1, divide by the new, so that gives us 8/3, because this is now going to be x to the 3rd, add 1, divide by the new, those match. We get a little bit of a break here, right? Because when we add 1, we get 2. So 2, if I instead of writing 12 divided by 2, instead of 12 divided by 2, I'm just going to go right to 6, just to save just a little bit of time. And then we're going from, unfortunately this time we're going from 2 to 6, so we're going to have to just crunch all the numbers. Other than that, you just take your time, grab a calculator now, slide it up just a little bit. But yeah, so now it's just negative 1/4, 6 to the 4th, 8/3, 6 to the 3rd, minus 6, and then 6 squared. Okay, and then minus, don't forget parentheses, just take your time, negative 1/4, 2 to the 4th, plus 8/3. I think this one causes it to be a fraction. All the rest, even the rest of these are actually not, there's no fraction, so even though it looks kind of messy, those all can reduce, but this guy's the killer. It's going to be, where were we at now? I shouldn't have stopped. 2 to the 3rd, and then minus 6 2 squared. Okay. Type all that in, and you should get 128/3. Now just don't forget this guy, right? My unofficial parentheses there. So I need to make sure that I take it times 2 pi. And that should give us 256/3 times pi. Okay. All right, let's stop there, and then I'll make another one to finish up. I have to make another video to finish up, what is it, sec7.3 part 1. So we're not even done with part 1, but that's okay. Everything takes time, we know that. All right, so let me shut this down and then I'll make another video.